today we're going to show you how to construct a general parallelogram and a rhombus. And this is using the understanding of circles, and that circles have congruent segments called radii in them. So we can use circle understanding. We also need to have some prior knowledge about how to construct congruent angles and how to construct congruent segments, perpendiculars and perpendicular bisectors and the properties of those, and also an understanding of lines. Like, how do you know when lines are parallel? Well, you should know the corresponding angles are congruent, and that's how we're going to be using this. I'm using a compass and straight edge, meaning no measurements, because we want precise constructions that really are focused on the properties. So this whole video is really about how do you help students understand why we use constructions with the compass and the straight edge, and it's because you can be very precise with the circles and the congruent measures of a radii. So I'm going to do a parallelogram first because it utilizes quite a bit of very first construction knowledge of how to construct congruent angles, and then how to verify something is parallel because you know that corresponding angles are congruent. So I'm going to get my geometry sticky here. Pull this up next to my thing. So I want to start as a student might, which would be with a straight edge. So on our tools here, I don't want to use actual measurements, and I want to use what is a straight edge. And so down here you see straight edge, and I'm going to use a line. And the reason is because I need the whole line to help me find those vertices of the parallelogram. So students should understand what a parallelogram is. They're looking to construct something that has opposite sides parallel, opposite sides the same length, corresponding angles are congruent, same side interior are supplementary, those types of things. So I'm going to start with a line. Doesn't really matter where you draw it, because again, this is dynamic, we can move it. So students would do the same on their paper. And the first thing we have to do is, we know we need four sides, and they don't have to be congruent. So the adjacent sides do not have to be congruent. So I'm going to use my line tool again and just make, a second side. So in theory, I have between these 2 points is a side of the parallelogram, and between these 2 points is a side, and I can change its length and that forth. So what I need to construct, to be precise about, is that the next side, the side opposite this one, is parallel to it, and the side opposite this one is parallel. So I'm going to change the color here, and we're going to show how circles come into play here. Now, this would be a construction students have done at the very first, which is to construct congruent angles. I know if I want parallel that I need corresponding angles to be congruent. So let's start with the one angle that we actually have here. So we're kind of looking at this angle between here. I'm going to get my compass tool. In this case, I'm using the circle tool because I can make a circle of any size. So if the students have a compass, they're going to put the point on this intersection of these two lines, and then just open their compass so that it intersects both of the lines. So they can have different size circles, it just has to intersect both. So here's one intersection, and I'm going to construct the other intersection. Students would put a point there. And so what they learned about constructing congruent angles is you're basically going to use these sides, which have congruent, not sides, these circles, the compass, to make congruent circles because they have congruent radii. So I want to make another circle at this other vertex that's going to eventually be a vertex of my parallelogram that is identical to this one, congruent. So this is where my compass and a radii comes into play. It needs to have the same radius as this circle. So I'm using a compass tool. They're going to use their compass tool. Basically, they're not going to change the width that they opened it, the radius. I'm going to use the compass tool and actually create and notice how it says up here, select 2 points. I want a compass opening a circle that is from this center point to this. So it's exactly the same. So notice that this is a identical circle to the one I started with, and I'm just going to basically, so students would actually construct the circle themselves. Oops. Not sure what happened there. Why? All right, I don't know why it's disappearing. All right, so students have made that circle. And I want to do another one because I need a parallel at this vertex as well. So I'm going to do the same thing. I'm going to basically make another circle that has the same radius as this one. So the first step is to use the understanding that all radii, if you have the same radii, the circles are congruent. So I've made congruent circles, right? And these intersect. Let's make the intersections here. Students would do the points. And now I need to basically make these two different lines. So I'm going to change my color again so you can see that I'm doing something different. I need to basically have this same angle opening here. And this one's going to match it exactly. So from this is the center going out to this. I want this to be the center going out to that. So I need another compass opening, another radius that's congruent to the distance between these 2 points. So students would put their compass here, open it to this point that intersects the other side, and that would be then the circle that they draw here with this point up here as the center. So let's get our compass tool here. And I'm basically going to make a circle that starts at the center, or open my compass to that width. So notice it matches that. So now I'm going to move it up here and match it there. And what happens is I'm getting this second thing. Now I want to do it again over here, but notice now I want to kind of match what's going on. So I really want this to be the center going to this point here. So let's do another compass opening. It's going to be the same opening, but it's nice to show that you're doing it different. And we're going to go over here and mark that construction. There we go. I want them to snap to each. So now I'm going to get the intersection here because that's really what I want. And I want the intersection here. And what I do now is notice that this center here, which matches this center here and this center here, is connected to the line. So I'm going to get my straight edge tool. Let's change the color again just to be consistent. And I'm going to now connect that line. So I'm looking for a line parallel to this with the center. So here's that center. And I'm going to use my line straight edge tool and connect these. And so what I've created is this angle based on these circles is congruent to this angle. And if these two are congruent, they are corresponding angles that are congruent, therefore these lines must be parallel. So notice I have to have some prior knowledge. And we're going to do the same thing over here. We're going to get our straight edge tool, and we're looking for the line parallel to this side. And so I use my constructions. Here's this point, and there's the line parallel to that. So now I have an intersection up here that we're going to construct. And so notice I now have the vertices of a quadrilateral, and opposite sides are parallel because I constructed corresponding angles to be congruent, making both sides, opposite sides, parallel. And as I change this, my parallelogram changes in size, but those parallel sides and opposite sides being congruent are now consistently the same. So now let's look at how to construct a rhombi. So it's very much, you could do it almost exactly the same except for one step where we want all the sides have to not only be parallel, opposite sides to be parallel, but all sides have to be congruent. So you have to add an additional step to basically constrain the sides that you start with. So now when we started with just two random lengths, right, that were adjacent. A joint had an intersection, so two lines, and we used the segments on those lines as our two sides. They didn't have to be the same, so we didn't have to constrain them. So we're going to end up doing the exact same process except for the first step, or the second step, really. So let's open another geometry sticky and just show you what I mean by that. I'm not going to go through the whole process. I am going to show you a different way to do the rhombus after this one. So again, I want to start with my straight edge, making just a line somewhere. And then, and this time I'm going to make my line, go up. We want to try to start our constructions different. So I'm going to use this segment that's on this line as one of my lengths, right? Obviously, if it's a rhombus, then all of those segments have to be congruent. So how do I guarantee that the next segment I construct is congruent to this segment between these 2 points here? Well, what's the only construct or shape or geometric figure that we know or are guaranteed that segments in it are congruent? That's a circle. So we're going to get our compass tool, and I'm going to use the circle tool here for me, and we're going to put our compass on one of the points. Does not matter which one, but one of the points. And actually, let's change the color so we understand what we're doing here. So let's make this red. So I'm going to put my compass on this point, and I'm going to open it to the same radius. So it's going to end on this. So the radius is the length of this segment that I'm using as the side of one of my rhombus, right? So now I know that any other radius I put on here is going to be congruent to this segment length here that I'm working with. So if I just make another one here, I know that from this blue point to this red point is congruent to the blue point to the blue point because they're both radii. So now I've constrained my starting segment length to be congruent to each other because they are now encompassed in a circle. And I can obviously change them, but they're going to stay congruent because of that constraint. So now I can focus on the parallel, which means constructing congruent angles. So at this point, everything that we did up here, and actually just move it up so that you can see, everything that we did here, we're going to now just repeat. We're going to make a circle at this intersection. We're going to use our compass and make a congruent circle here and a congruent circle here so that we're really focusing on parallel. We're going to measure the distance. We're going to open our compass to the distance between these 2 points and make congruent circles here and here, and then connect the line. So it's exactly the same process once you get to this section, but first you constrain the congruency for the rhombus by using a circle, so that unlike a general parallelogram, these two adjacent sides don't have to be congruent. They can be, but they don't have to be, but they have to be parallel. So for a rhombus, you start slightly different by adding in that constraint of the circle to control the congruent sides, but then you do it exactly the same as a parallelogram. So I'm not going to go through that. I want to show you a different way you could think about the rhombus. So let's open another one. And so we know that circles give us congruent, right? So if I have a circle, right, and I have a radius here, I know that if I make another radius somewhere that it's going to be congruent to that one, right? That's a given. So is there a way for me to use a different circle to get more different sides in? So let's erase this circle, not circle, that radius. So let's make a congruent circle to this. And how do we do that? Well, if from here to here was a radius, then I can make another circle that has a different center but the same radius by using those same 2 points. This is your compass again. You're going to put your center on the point on the outside of the circle and open it so that it hits the center. So you know you have the same radius in both, right? This is the same radius in both. And so this construction should look kind of familiar to everybody. This is actually the construction that students should have done before of a perpendicular bisector, which means that these two intersections of these two congruent circles, so this is prior knowledge again coming up, are equal distant because they're basically radii. So the point from here to here is a radius, and from here to here is the same radius since the circles are congruent. So this point's equidistant from these two. And this point right here is also equidistant because of the same reason. It's a radius. And so all these segments, so if I get my segment tool now, or my straight edge, let's think of it that way, and let's change the color, and I connect them, this segment is congruent to this segment because they're both radii, and this segment's congruent, and this segment. They're all radii of two congruent circles, so they all are congruent. So I have just now made all my sides congruent. So I have a rhombus. How do I know that this is how opposite sides are parallel? How do I know that? Well, this is an enclosed quadrilateral, right? And this is a, if I were to connect this is, there's a perpendicular bisector here, right? And so I know if this is a perpendicular bisector that these two diagonals of this rhombus are intersecting at right angles, and that is a definition of a rhombus, and they're bisecting each other. So there's a lot of properties that show up by constructing the rhombus this way that you're verifying. And notice you can change the rhombus by changing the center, but you are a little more constricted with this rhombus because you use circles to construct it. But just different ways to think about it and think about using properties.